We're here in the Guamot Forest Reserve in Middle Borneo, and we're demonstrating right now a forest application using RFID and the symbol MC9000 or 9060 terminal linked to a laptop. What we're going to be doing is downloading the information. We're going to read a tag, download the information, and synchronize it to the laptop from the handheld unit. And then what we'll do is attach it to the tree here that we're going to be felling in a couple of minutes. Here's the process of attaching the tag to the tree prior to the cutting and the felling of the tree. In real life this would be attached more permanently to the stump, but for demonstration purposes we've just placed it at the bottom of the tree. Okay, here's the tree, it's coming down. It's coming our way. We'll now go and check the status of our tag. So this is what we would normally do, is after the tree was fallen or felled, what we would do is attach the tag to the stump or either to the tree itself, and then we would simply scan it and then record that information and link it to the computer for later processing. So we can put it on the stump, or clear that out. We could put it onto the tree itself and still read the information. Symbol's RFID solution is based around an armored reusable 2x4 Gen 2 RFID tag. This tag is attached to the end of a log via the use of a steel cable that allows it to move and swing to minimize the risk of shearing off should it be struck. Felling the tree is just the first operation that requires tracking. Felled trees are dragged to the side of the road where the bark is peeled off. Because of this, tags need to be placed on the ends of the logs rather than on their sides. Transported logs are stacked and labeled according to such criteria as species, diameter, quality, and area felled. Currently, all this information is written or chiseled onto the ends of the logs, and then the inventory is manually recorded by workers onto a sheet of paper. Incorporation of RFID can automate this process, making it both quicker and less error-prone. Logs are loaded onto trucks for transport using end loaders with claws. The need for sturdy tags is evident, as logs can roll and hit each other and can only be moved by using heavy machinery. After the logs are loaded, a worker manually records each log on the truck and generates a paper manifest, which accompanies the final transportation of the logs off the premises. Transportation roads are unimproved, and the logs being transported can vary in length considerably. Final accounting of the logs takes place at the exit gates. Currently, the guard physically inventories the logs and compares them to the manifest. Incorporation of RFID changes the guard station from this to this. Logs can now be automatically read and inventoried, with data transmitted in real time to headquarters for tracking and reconciliation. When developing and demonstrating RFID solutions, customers always want to know how well the tags will perform in their particular environment. For example, can you read them when they're buried in mud? Symbol's up to the task, no matter what the customer wants to try. Oh, it still reads!
Quite interesting.
Still reads while covered with mud, so now what we're going to try and do is see how much mud can we put over it and still read it.
Oops.
No, I've got to reset my program here. Still reads. So this kind of shows you that dirt is not really a problem for putting this on here. Go ahead. And we'll read it again. Yeah? Oh, I have to go and try and find it now. All right. So we found it. As long as you know where to look, you should be able to read it pretty well. Oh, I found it. Okay. So it's underneath about 6 inches of fresh cut wet wood. We could probably put it inside the crack if we wanted to. still reading.